We talked about a dozen properties of numbers in our previous lesson. Today we're going to focus on a specific one that gets used a whole lot, and that's the distributive property. So there's two main uses for the distributive property, and as far as what you need to know and learn mostly is the first one. It's that we need to distribute when variables are involved. And once we get to some examples, I'll explain why they make a point of it being when variables are involved. Now, I'm also going to show you how the distributive property can help make multiplication without a calculator simpler. But this element I am going to show you, but it's not going to be required that you be able to do it on a quiz or test. It's just more so to help you with mental math, to make things easier for you. But this first one you do need to know for this class and beyond. The distributive property is something that's used when we have a term outside of parentheses, and then inside that parentheses there's two terms, B and C in this case, that are either being added or subtracted. So let me go ahead and tell you one time we would not need the distributive property. If you see that, there's no need for the distributive property because there's nothing being added or subtracted inside. You would just say 2 times 4x is 8x and be finished. But the idea, people often draw these lines, they say, okay, A is being multiplied by both B and C. So we do A times B, which is what gives us this term. We just keep this sign the same, and then A times C, which gives us this one. And the second line is identical, it's just it's a minus instead of a plus. Okay, now as you look at number 1 and number 2, you notice they don't have variables. We don't have to use the distributive property on these. Let me do it with the distributive property and without. But I want to show you why. I put these on here just to show why it's when variables are involved we have to do it, but I don't plan on a quiz or test. If you have ones like these, you can do it with either format I'm going to show you. So with the distributive property, we do have the pieces we talked about. We have a term outside the parentheses, the 3, and then two terms inside, 2 and 5, being added together. So I do 3 times 2 plus 3 times 5. 3 times 2 is 6. 3 times 5, sorry, looks like I was getting ahead of myself there. 3 times 5 is 15, and 6 plus 15 is 21. So the distributive property absolutely does work on this. It's just not required, and let me show you what I mean. If you think about the order of operations, the first thing order of operations tells us to do is whatever's inside the parentheses. So another way to solve this problem is to say 2 plus 5 is 7, and 3 times 7 is 21. So we get the correct answer either way there. So let's see how that shows up as well on number 2. We have 4 times 9, which is 36, minus 4 times 7, which is 28, and 36 minus 28 is 8. Sorry. But because there's no variables here, and that's the key, there's no variables here, we could just as easily have followed the order of operations and said we'll do what's inside the parentheses first, 9 minus 7, and get 2, and 4 times 2 is 8. So we get the same answer either way, and you can do either one on a test or quiz when you have a question like this that has no variables. So as you look now at number 3, it does have variables. In fact, the rest of them here do. So we can't just use the order of operations on this one like we did on the previous ones because 2x plus 3, 2x and 3 are not like terms. We cannot combine those two. They won't combine. This one has an x, this one does not. So the only way for us to simplify this, notice that simplify, not evaluate, these two did come out to numbers and that's fine, but the rest of them won't come out to just a number. We'll do 5 times 2x plus 5 times 3, and we'll get 10x plus 15. And that's as far as we can go, and that's fine, because we're just trying to simplify it. But there's no like terms here. This has an x, this does not, so we cannot combine those. Okay, number 4 shows us we can also do this when we have negatives out front. So that's negative 6 times 4. A negative times a positive is negative. And then when you're multiplying by this, treat it as a negative x. That way you're including the subtraction here. So just think of it as negative 6 times negative x. So it gives us a positive 6x. And you're welcome to leave the answer like this, or you want to switch the 6x to the front, that's fine. Either one of these answers are good. Just make sure you keep the signs if you do switch it. That's a positive 6x, so it stays positive here. It's a negative 24. So we can write plus negative 24 or minus 24 right there. Number 5, 4x times 3x. So 4 times 3 is 12. X times x is x squared. Minus 4x times 5. So 4 times 5 is 20, and we keep the x. So the good thing about these is it really doesn't take that long of a time. You just got to make sure you're doing things correctly with the multiplying. Okay, number 6, this time we have 3 terms inside. We still do the exact same process. We just multiply every term inside by 4. So we will have 3 terms in our answer, but that's the only difference. The rule is still multiply everything on the inside by what's on the outside. So 4 times 6 is 24, and we keep the v squared. 4 times v is 4v. 4 times 3 is 12. So yes, even with longer or more terms on the inside, we still use the distributive property. This is really just the basic version of it. But you can have 3 terms. I don't know that we'll have any with 4 terms, but you could do it with as many terms as the math teacher or math book desires. Okay, this one may look different because the number on the outside is put on the right side instead of the left side. That makes no difference in how we do the problem. So they could write it 3w minus 5 times 7, or 7 times 3w minus 5. It doesn't matter if that 7's on the right side or the left side, we still do the exact same thing. 7 times 3w is 21w, minus 7 times 5 is 35. Okay, number 8, negative 6 times r. Okay, negative 6 times 3g is negative 18g. And then negative 6 times negative t is positive 6t. Okay, now on the back, we're just talking about adding like terms. So this is not the distributive property. We finished that on the front. We're just making sure we remember how to combine like terms. So on number 9, both of these are like terms because they both have a u, and it's u to the first. There's no other power involved. So we would just say 17 u's plus 5 u's is a total of 22 u's. So things are like terms when they have the same powers and the same exponent. So as you look at number 10, this has no like term. There's no other t squared. There are other t's, but no other t squared. But these two are like terms. So I just have to rewrite 6t squared. But this is 3t minus an understood 1t, so that will give us 2t. Six n minus 4n, those are like terms. They both have n, so the answer is 2n. And what I prefer to do on these is start with the biggest power. So I see an a squared here. There's no other a squared. So I just write, including this negative sign, I just write that first. It's not required to do that. That's just the normal pattern, is to start with the biggest exponent, move down. But then these two are like terms. 7a minus 2a is 5a. And then we have a constant, a number without any variables right here, so it just stays the same, plus 4. So now we're told to write an algebraic expression and then simplify it. So we have 2 steps here. First, we're going to do what we've been doing before. Sorry, can't get this all lined up. Let's see. Ooh, sorry about that. All right, so first we got to translate this into an expression, an algebraic expression. So 3 times the difference, okay? So 3 times, and difference means subtract. So we need to put parentheses around it because we're supposed to triple or 3 times the whole thing over here. So 3 times the difference of 4 times x and 7. And I put subtraction because it's difference. So this is step 1. We wrote the algebraic expression. Step 2 is we'll simplify using the distributive property. So 3 times 4x is 12x, and 3 times 7 is 21. Okay, 14, twice the difference. So 2 times the difference of 3x and y, so 3x minus y, increased by, remember this is plus, increased does not ever mean multiply, increased by 5 times the sum of x and 2y. So we add x and 2y. But just to enforce, the reason we need these parentheses is we're supposed to multiply this whole sum by 5, not just one or the other. We're supposed to multiply the whole sum by 5. Same over here. We're supposed to multiply the whole difference by 2, not just one piece or the other. So now that we have the equation, or the expression I should say, we use the distributive property. 2 times 3x is 6x. 2 times y is 2y. Plus 5 times x plus 5 times 2y is 10y. But we're not finished yet this time because we have some like terms we can combine. So 6x plus 5x are like terms. And 6x plus 5x is 11x. Then negative 2y plus 10y. Or if it's easier, think of it as 10y minus 2y. So we'll get a positive 8y there. So it's up to this point you have to actually know the material and be able to do things similar to this on a test or quiz for me. And you'll see stuff similar to this in classes beyond Algebra 1. So if you don't want to watch the rest of this, truly that's fine. But I'm going to show you some ways this can help you with some mental math or even doing it on paper and just make it a little bit simpler. So truthfully, when we see 15 times 304, we're kind of like, I want a calculator. But 304 is pretty close to 300. So here's a trick we can do that makes this a little bit easier. If we want, we can always try to get close to a number we do know or was easier to work with. So I'm going to rewrite 300 as 300 plus 4. So I'm kind of creating for myself a distributive property situation because I'm separating 304 into 300 into 4. And the reason I chose those two numbers is because this is a lot easier to do by hand because 3 times 15 is 45, and then we just put on the extra 2 zeros. 15 times 4 is 60, so we just add these two together and get 45, 60. And I think that's certainly a lot quicker and easier than us doing, the long way with multiplication like this. So we're going to do something similar on 16. We don't normally think about multiplying something by 2.5, but multiplying by 2 is easy. So let's split this up so it's 2 plus 1/2, because this is still identical to what we started with. 2.5 is the same as 2 plus 1/2, and I can do this math much simpler. 44 times 2 is 88, and then 44 times 1/2, or think about it this way, half of 44 is 22. So then I just add the 2 to the 88, that's 90, then add 20, and I get 110. Okay, 210 times 5. So we'll do something similar here. We can split this time we'll split up the first number. 210 is the same as 200 plus 10. 5 times 200 is 1,000. 5 times 10 is 50. So we get 1,050. Okay, now 18, you might think, well, 49 is a long way from 40. It wouldn't be that hard to do this one by making this 40 plus 9. But if you think about it, when we do sorry, the distributive property, we can do it with both adding and subtracting. So it's not that you can't make this one easier by making 49 into 40 plus 9, but what would probably be even easier is to think, well, 49 is actually closer to 50 than it is to 40. So rewrite that as 50 minus 1. Then you do 7 times 5 is 35. Add the 0. 7 times 1 is 7. So 750 minus 7 is 343. So I think this is really cool. I think this is how a lot of people do mental math, and it's just a trick that no one ever teaches you, as much as some people they start to figure out, oh, it's close to this. So I wanted to show it to you because it can be a way you can do stuff in your head a little bit easier when you learn tricks like this.